Hello, this is Robin again. It's Saturday morning and I'm up way too early, so I thought I would take a look at the free CodeCamp daily challenge. Today they're starting a Space Week thing. So today's title is Space Week Day Stellar Stat Classification. It says October 4th marks the beginning of World Space Week. The next 7 days will bring you astronomy-themed coding challenges. For today's challenge, you're given the surface temperature of a star in Kelvin, K, that's not Fahrenheit or Celsius, and need to determine its stellar classification based on the following ranges. And they give us a list of ranges. Um, so it's 0, which is 30,000 K or higher. B is 10,000 to 29,000, and so on until we get down to M, which is 0 to 3699. And it says to return the classification of the given star. So again, we have code in the middle and the output on the right. And if I scroll down, we can run tests. So if we run tests, it tells us what it should return. And of course, they're still failing because they're just the brand new thing. So here we have a function called classification, which passes in a temp or temperature and returns the temp. So yesterday we had a thing that had a similar type of thing where it was returning a value based on something else. And I'm going to try doing that. So what they did is they had a series of return statements and if statements. And if we did, if temp is larger or equal to 30,000 without the comma, return, I think that's, oh, we're 0. I'm not sure. I think that's a 0. Let's try that. It'll tell us if we're right or not. And then if it does that, it's going to return and not evaluate the rest of these. So we're starting from largest to smallest. So if it's larger than equal to 10,000, return B. Now, if I have this correct, anything from 10,000 to 29,999 will fall into this range because everything from 30,000 and up is already returned. We'll do a couple of these and run the tests and see how we did. And then we'll finish it up. 7,500. Return A. Let's run tests. And it looks like a few of these have already passed, a couple. So 9999 should return A, and 11,432. 210,000 should return 0. Now that should have gone, unless it's an O. That could be an O. Let's try an O. There it is. Okay, so we had a wrong value, so that's an O. It's hard to tell from the screen. So the 0 has a slash through it. Okay, so far we're on the right track. Temp is larger than equal to 6,000. There's a few of these. Return F. If temp is larger than equal to 5,200, return carriage return G. If temp is larger and equal to 3700, probably could just copy and paste these lines and make it faster. Let's leave the last one out and do a test real quick. Now we're missing 2400 and 3699, which would fall into the last category. Now we can assume that this last one is going to just be what's left over. So return M. That's it. Okay, so that said, yesterday I was talking about maybe if JavaScript had a switch statement. So let's go look that up real quick, because that's a different way to do that. So the way this is set up, it provides a way to control the flow of execution based on the value of an expression. It's basically the same as if-else if statements or a series of if statements. Um, you pass in a value, and then these case statements are line by line to decide whether it falls into a range or some sort of expression. It'll put code and then do a break and fall out at the bottom. The default is the code to execute if no case matches. In this case, that last value. So if we were to do this, and I'll just paste it in here for reference. Actually, let's just paste this in up here. So default code would be return M. And we're going to the switch. It's going to be the temp. Value 1. So let's copy this. And return 0. Or O. I'm not going to do this for all of these, but value 2. Now this may have to, might need a range. Oh, the break will make it fall out. Okay, so if you notice this just grayed out, so that means all of this is going to execute. Let's do a couple of these as tests to see how this turns out. And as you can see, these actually do work. A couple of these, 36.99 to return M. I'm a little surprised this did not get more of them. Oh, that's because they're the wrong values, of course. So if we were to do, I'm not going to do all of them just because I want to show just the example of this. So the next one would be 7,500. Return A. Let's do one more. Hopefully we'll have some of these work. And 6,000. Let's do one more. And we'll still have a few failing tests. Okay. This might be wrong. Okay. All right, I'm gonna do the rest just because I'm not sure about this. Oops. 200 should return a G and one more. Could be we need the range of these. So a greater than, less than, and less than equal to. Let's see if this improves it a bit. It doesn't appear to have. Okay. That's the general idea of how they work. I think a lot of times you use an equal, equal, equal on these. So let's do a quick check with ChatGPT and maybe I'll ask it why that's not working. For this JavaScript coding challenge, and we paste in the problem. Shift Enter because it will submit the thing. And I'm going to say, let's try this one first. I have this code that's not working. Let's put the extra semicolon at the end. Oops, I got to get me because I didn't have the closing semicolon. This case labels must be values, not conditions. To use conditions like temp is larger, you must use an if, else, if instead. Okay, I had a suspicion that wasn't going to work. So we would have to do this instead. So if temp is larger than equal to 30,000, I return O, else if temp is larger than so on and so on. Let me know if you want to do this in a fancier, shorter way, like with an array of ranges. That's interesting. Let's delete this and go back to the original and see what it thinks about it. Quick check, does it work? It still works. Okay, no mistakes. So, okay, switch statements would have not have been the correct answer if and else if. Otherwise, maybe this should work. Let's try this. About this code. Yes, it's 100% correct. Clean and efficient way to handle the problem. Using early returns in descending order of temperature, which ensures the correct classification is returned as soon as the condition matches. No else or nested structure is needed because each return exits the function immediately. Slightly more compact version with the same logic if you wanted to make it a one-liner per condition. Okay. Constant classification equals temp, and there's a pointer. And it does these temp is larger than equal to 300,000 question mark O, question mark B, A, so on, and defaults to M. This is kind of like that switch statement I was talking about. It's a slightly different way to do it. What are other ways to solve this problem? Five alternative approaches, an array of ranges. This approach uses an array of thresholds and finds the best to match. Okay, so we have a minimum of, so we have this array. It's kind of a hash table or a dictionary lookup type of thing. So minimum 300,000, so that's the value of this field. And then we have a class, which is OBAF. Okay, I don't care about that. No, this little pop-up I meant. How do I get rid of it? Okay. Return ranges dot find. So it does a find across the range, the temp, and the range min, and returns a class. May have to explore that one at a different time. That's an interesting way to do it. Easy to modify and easily readable. Slightly slower due to iteration. But if you had a very, very large array, this would make a difference. Switch true. Okay. This uses a switch with true as the expression. So we were kind of on the right track. We're passing in the temp instead. Okay. So it's expecting a true. And apparently you can do a Boolean evaluation here. Interesting. I'll have to remember that one. Says a slightly weird usage of switch may confuse readers. Yeah, that confused me a little bit, but that kind of makes sense. A binary search for larger data sets, overkill, but worth knowing. If you had 100 plus ranges, this would be faster than the find done in the first one. So we have two arrays, one with thresholds, and here are the values, and the constants are, the classes are an array of the same size, which is a separate array instead of a dictionary or a hash. Let I equals 0, I is less than threshold's length, so this is going to loop through these. And if temp is larger than equal to thresholds, return the classes with the same index, which would match up. Sounds like this would be a little harder to set up, but especially if we had a larger one, but easy to extend with binary search, not needed for 7 items more code than necessary. I would agree with that. The one problem that we have with just doing returns is if the values change, then you'd have to change all the code. Could be a little clunky and hard to manage. Using a map of functions, this is mostly for fun and learning purposes. So this is a type of array also. It's also a type of way of declaring an array. Temp is larger than that and that, so it's kind of like doing a Boolean. Checks map and find by Boolean if it's true or not. Probably not something I would normally do. Nested ternary operators, not recommended. Hard to read and maintain. I would agree with that. But I think the way I had it was a little hard to read and maintain too. Most real world cases would use if else or the early return. So like the way we did it. So we've got a couple pros and cons for each of these. Let me know if you want to see a version that validates the input or throws an error on negatives. Okay, we did not do any validation. Interesting. Yes. Show us some validation examples. We do want to validate in most cases. Ensure the temp is a number and non-negative. So we're going to check the type of the temp to see if it's a number. And is NaN means is not a number. And that means or is not a number temp. So we're just checking to make sure it's a number. If there's a letter in there, then we would throw an error. If temp is less than 0, throw a new error. Temperature cannot be negative. Then we do our returns. So just a couple extra if statements to just make sure everything is correct. So if I said classification hot, it would return an error. If it was negative 100, temperatures can't be negative in Kelvin. In Fahrenheit and Celsius, though, that would be different. Return null or unknown instead of throwing errors. This is a design choice. Some apps prefer returning a fallback instead of throwing exceptions. So if the type of temp is not a number or is not a number temp or is less than 0, return unknown. Okay, that's one way to do it. And TypeScript, we could talk about that later. TypeScript is a way to actually set up types as a type of number or a string. A little more advanced. Use number to coerce strings if desired. So if we're accepting a temperature input from a form, you may want to coerce it. In other words, force it to be a number or try to cast it or convert it. So constant temp equals number of the input. If not number is finite temp, okay, sure what is finite does, but so there's a couple different ways to do it. And if you want a version that supports temperature and Celsius or Fahrenheit with automatic conversion, I'm not going to do that right now because that's just a little bit much. But all right, that's what ChatGPT's opinion is on this. I think, in my opinion, I would probably stay with what I have, add the validation. The code challenge does not require validation, at least for this particular one, but it's something to keep in mind for future pieces, or if you were doing this for real, you'll want to double check to make sure nobody's sending you bad data and trying to trick it, or try to get access to things they're not supposed to. So you always should validate data if possible. So I think that's all I have for now. And we'll try this again tomorrow. Looks like there's more astronomy related things, so that looks pretty cool. All right, thank you.